Hello everyone and welcome to this re-recording of my Articulate Guest webinar that took place on June the 11th. My name's Chris Hodgson and I'm a digital learning solutions developer specialising in digital learning and online learning environments. My company based in the UK is called Discover eLearning, which has been my personal and professional brand name for close to 10 years now. Now, my session today is called Unlocking the Senses, and I'm going to be taking you on a journey that explores how the nature of interactivity between ourselves as users and our devices has ever evolved and continues to evolve going forward, and what that means from the context of learning experience design, the opportunities that exist today, and the decisions that we can decide upon that can make powerful changes to the way our experiences can be accessed and engaged with. I started things off with our audience on the June 11th with a question. Which one of these individuals on screen here is most likely engaging with an e-learning experience? And maybe that is a storyline built experience. Now, it's likely that you've immediately got the point that I'm trying to make with this, probably even before I even give any answer here, even though technically there kind of really even isn't one. But the fact is that, say, 20 years ago, when I roughly started my career in online learning, I was working for a Northeast England university, and the girl in photo A would have absolutely have been our primary persona, as it were, for who our users would be engaging with the content that we were building at the time. But now we have the girl on the train taking the opportunity to practice her French spoken language skills with a virtual AI coaching app that is capable of performing voice translation as well as pronunciation analysis. The man recording either a photo or video on his phone, engaging with his real-time omnimodal AI assistant, ready to guide him through a step-by-step tutorial on how to install components onto a Raspberry Pi, or how to do repair on his bike if he's got himself a tyre puncture. And our guy in the bottom right there, he fits the profile of a gamer jumping onto the latest console release, but in the end of the day, the gaming controller is just another mode of interface between ourselves and the computer, giving us the means to control and instruct our digital experience of our intent, which, depending on the context of the experience, might deliver a more meaningful and comfortable method for the user to engage with our specific learning experience. But today, of course, we're focused on Articulate Storyline, and we all know about the huge range of interactivity options that Storyline gives us through its trigger events. They're right here in the When panel when we're setting up our custom slide triggers. But you'll probably have noticed that there's no option here specifically relating to voice recognition triggers or nothing for game controller interaction, for example. So does that mean that these kinds of interactive methods are out of reach for Storyline developers? Well, no, absolutely not. And that's largely thanks to one specific trigger, which you can set up as your action, the execute JavaScript trigger. Now, JavaScript is an extremely powerful and versatile coding language for the web, and this ability to write and load in our own custom scripts within a Storyline project opens up a wealth of possibilities that we, as learning experience designers, can tap into to create entirely new forms of user interaction. Often we can achieve this just by using features already built into the modern browser, but we can also go further than this, connecting Storyline with third-party systems like generative AI platforms, in secure and controlled ways. And that is when we really start to unlock unprecedented levels of interactivity. And what I'd like to do during my session today is showcase to you a wide range of cutting-edge interactive capabilities that are within reach of all Articulate Storyline developers. Now, this won't be a tutorial session on how to do everything that you're going to see. That may, in fact, be something that we do together in maybe in a future session. But right now, I'd like to show you as many demos as I can to help spark ideas in your mind that might be something that you will go away and explore within the context of your own organization or ongoing projects. And as the name suggests, I've categorized everything that you're about to see into each of the 5 senses. And I know you're already raising your eyebrows about what we're going to come on to when we get to smell and taste. So all I can say about that is just stay with us to find out. Okay, we're going to start with a look at sight. And what I want to do is show you here, what I want to show you is not in relation to what the user themselves are seeing on screen or on the slide, but instead what the digital learning environment itself is capable of seeing, both on screen, but also directly looking at us, for example, via our webcam, and how that can lead to new methods of user interactivity to perform and guide actions. Now, you've likely come across the term omnimodal a lot in generative AI terms, especially in the era that we're currently experiencing. The idea being that not only can large language models be trained on vast quantities of text-based knowledge, but it can also have the ability to recognize patterns in sound as well as image data. Now, who remembers GPT-4 Turbo? It feels like a lifetime ago already, but this was OpenAI's flagship model only 1 year ago. And I remember vividly the day that the vision modal capabilities were added to the OpenAI platform API, because I had been patiently waiting for days for news to come as my mind was racing with so many ideas that I wanted to try building for vision-based input in Storyline. And this is one of the first things I attempted to build with this API. And by the way, I'm showing this to you as a video, the reason being that attempting to swap webcams between apps can be a little bit problematic, but you'll see some live demos coming up in this presentation shortly as well. So if I go ahead and click play on this, what you can see is happening here is that I have superimposed a canvas element onto my slide that contains a getUserMedium method in JavaScript in order to bring my live camera view onto the Storyline slide. Then I have a second script connected to the blue button there on screen, and this creates a snapshot of that camera feed at the moment it's clipped, and that converts the image into a raw base64 code format, which is the format that the OpenAI API accepts when passing image data as part of a structured create chat completions API prompt, in effect like a ChatGPT action and response. And all of this, by the way, is managed by my own WordPress plugin for Articulate Storyline called the eLearning Magic Toolkit, which I might speak more of a little later on, but this is taking care of the authentication and data transfer to the OpenAI platform, which then delivers a response based on the hand shape that I'm making. And as you can see, the end result is to update the state of an emoji image on the slide to match that shape. So this was a terrific result, as it demonstrated that there's possibility there, even in a busy image like you can see going on with my room behind me, for a user to control an activity using nothing but their camera and their hands, completely hands-free, as it were. And building this into an actual full Articulate Storyline activity, building a quiz seemed like the next logical step. And what I'm going to play for you here is a clip that shows that result.
Welcome to our quiz. See if you can correctly answer these questions. According to Digital Accessibility Group, what percentage of people living in the UK have digital access related needs? Is it option 1, 5%, option 2, 10%, option 3, 15%, or option 4, 20%. Hold up the number of fingers to your webcam that corresponds to your chosen answer. It looks like you've chosen option 4. Is that your final answer? Give me a thumbs up if you are happy with that, or a thumbs down if you would like to change your response. And the correct answer was...
Okay, so we're able to clearly work with images via the API at this moment. And as you saw there, the input that I was giving through my webcam, being translated into an action via the OpenAI API platform, had a little bit of lag between the moment that I went ahead and gave my answer and the trigger action taking place in Storyline. But we are now seeing a new wave of large language models like Google Gemini, for example, that via their proprietary app can engage with users via live camera as a continuous video. So I think it's only a matter of time before continuous real-time interactivity via webcam should also be possible, reducing the lag time right down. Now, staying with vision capabilities, I want to show you this second demo, which relies upon the same AI technologies, except this time, the image that we're going to be passing in is not of ourselves, but it's going to be of slide content itself. So Daisy here is a friendly and supportive art critic, and I'm going to attempt to draw something live right now, and we shall go ahead and see what Daisy has to say about it. Okay, so I'm going to go ahead and kind of do the same kind of strange thing that I ended up recording on the stream itself. So I went ahead and created a sort of cup of either coffee or tea here. I've only got yellow to play with, so it's something along those lines. And then we'll add some heat waves coming off there. But not only is it a cup of tea, but turns out this is actually T-Man flexing his muscle. That might be construed as a teapot spout, actually. So I'll see if I can maybe give him let's give him a green hand for some reason. And then let's give him an expressive look on his face there. Okay, so I'm now going to go ahead and see what Daisy has to think about this. So what's going to take place is effectively a chain of actions within two separate AI models. So first of all, the image is going to be transmitted over to the OpenAI API, and it's going to review the content of the image and effectively provide a critique or provide a kind of helpful summary report, as it were, on what it is seeing with regards to that image. And then that's going to come back as the script, as the voice of Daisy. And then that content is then going to be sent straight to the 11 Labs text-to-speech API, which is then going to convert that text content into a high-fidelity voice print that can then be brought back into Storyline in order to then be played to the user on the slide. And then I've got a separate layer that just has a bunch of mouse shapes that effectively just loop whilst the sound is playing. So effectively there'll be animation playing whilst the voice is also playing on the slide. So let me go ahead and click the button and show that to you in action.
Okay. Right. Okay. Your drawing has a delightful whimsical charm. The bold lines and expressive face give the character great personality, and the steam adds a sense of warmth and coziness. The playful use of colour, especially the bright accents, enhances its lively spirit. The creative design of the arm-holding greenery adds a touch of humour and originality. Well done.
So there we go. I'm feeling quite good about myself and my rudimentary capabilities as an artist right now. So Daisy herself is not designed to give constructive criticism per se, because that's ultimately how I have designed her for this demo through my prompt engineering. But if we wanted to give her a specific objective to guide the user on regarding, for example, their artwork, then we could also do that. Okay, lastly, as a bit of a bonus entry for the topic of vision, I also wanted to show you the advancements that continue to be made in the area of face and eye tracking, simply via standard 2D webcam technology. And this project that you're seeing here, called webgazer.js, is in fact a JavaScript-based library for providing rudimentary eye positional tracking in relation to the user screen. The one thing about this was that it was quite difficult to set up, as it were. It was by no means straightforward, but as I mentioned, I do love a good challenge, and I'm going to show you the result that I managed to achieve implementing this into an articulate storyline based slide here. So when WebGazer.js initiates, it goes ahead and finds my features on my face as well as my pupils in order to determine the direction that I'm looking at on the slide. And as you can see, as I move, as I start to look in different directions, the pointer on the screen is updating itself based on the direction that I'm looking, and roughly in that direction. So the interactivity that's taking place in Storyline, if I go ahead and replay that, is based on the X and Y coordinate value coming from the marker position. And the trick, of course, is to make the interactive elements on slide as big as possible. So the triggers are just simply changing the state of the L image when the X value, when the X positional value is below 50%, and to change the R image when the X positional value is above 50%. Okay, so you've just seen two quite ultra-modern methods of user interactivity developed through Storyline that are all based on vision capabilities within the learning environment. Just before we step away from vision as a topic, if you enjoy playing video games and are looking for some further inspiration, I would highly recommend checking out a game called Before Your Eyes, which is a BAFTA-winning, story-rich game that is controlled entirely by your webcam. So in effect, all of the story and actions that you take throughout the game are completely controlled by the direction that you look and by opening and closing your eyes. It's something truly special, and I don't want to say too much more about it because really what I want you to see it for yourself. And it is a great time right now because this game is currently on sale on Steam for just $1.99. So it's an amazing game, and please do go and find it. Okay, let's now move on to sound. And in this case, we're talking about how a user can engage with the learning experience using their voice, and how the experience then communicates right back in perhaps ways you might not have seen before. Now, for the longest time, voice recognition taking place just in the browser has been possible through a web API called the Web Speech API, which was capable of recognizing speech via the microphone and providing the ability to dictate what is being said to a somewhat accurate degree. This, however, was not always wholly accurate as one would have hoped, and there were limitations on the number of languages supported, and also the Web Speech API itself was not accessible to all browsers, even some quite modern ones, so it wasn't the most accessible option to work with. What I'm going to show you here is one of my first projects attempting to implement this web API for an eLearning Heroes Challenge entry many months ago, way before anything like ChatGPT 3.5 was available, and you'll see that working with single words often achieve the best result.
Circle menu. French. Circle menu. Spanish. Circle menu. English.
But we're now living through a revolution in text-to-speech and speech-to-speech user interface, and all of the capabilities that this offers. What I want to show you are two demos here, but you've likely already seen the idea of an AI knowledge chatbot being connected to learning content, the user effectively asking questions and the AI giving answers just like ChatGPT would. And this is not what I have here. Instead, what I want to show you is what I think is the next level, another term that you've also likely encountered called agentic AI. And that is the capability for AI to perform actions on the user's behalf based on its instruction and understanding of the context and environment in which it operates. So in effect, we are able to make it clear to our AI agent what the user is engaging with, i.e. what is on the slide, and also the actions that the user can take. Then we can start to program the same actions being possible for the AI to trigger via JavaScript. And here's the first demo, which as you can see is kind of standard articulate storyline activity. On this first slide here, you can see I've got two text entry fields. They're just the standard text entry fields that you find in Storyline connected to variables. So I can come in here and obviously just type into them as I usually can in Storyline. But what I'm going to do is activate my voice agent, which is an 11 Labs conversational AI agent, which I have programmed to have context of what is going on the slide. And let me show you what this is capable of. Hi there, I'm just checking you can hear me okay?
Yes, I can receive and respond to your messages. What would you like me to help you with?
Okay, I'm currently on a slide that has a first name and a last name box. Could you please write Chris into the first name box and Hodgson into the last name box, spelled Hodgson?
Done.
So there we go. The agent has gone ahead and written or updated those variables, which in turn has updated what I'm seeing on the screen as a result. And I can still come in here and make updates as normal if I wish to do so. Now, this is all part of the agentic actions which I've effectively programmed for the AI to have control over within this activity. That can include, in effect, any trigger that we want to set up within our storyline activity that we want to then make the AI agent aware of as part of its context. So that can, of course, include navigation triggers. Okay, I'm ready to move on to the next slide now, please.
Done.
Okay, so on this slide, I have an image here, and using the JavaScript API, I'm going to use my agent to control its fill property. So in effect, I can tell my agent what color I want this circle to be changed to. Can you please change the fill color of the circle to red?
Done.
Okay, I'd like to change it to yellow now.
Done.
And let's finish off by changing it to green.
Done.
Brilliant. So they're all web names, as it were, for colors. So it's going ahead, updating those properties in CSS, and then we're able to see those apply to the image that's on the slide. Okay, one more thing to show you. Let's now navigate to the next slide.
Done.
So this is a freeform drag and drop activity, which you typically hear about in Articulate Storyline, not necessarily having the greatest accessibility options. Hopefully that will be something that will improve and we'll see changes being made in Articulate Storyline in the future. But with regards to what we can do here, we can also ask our AI agent to go ahead and move that shape for us into the position where we want it to go. I can see a B shape on the slide, and could you please move the B onto the hive for me?
Done.
And now that I'm basically happy with my selection, I can use AI once again to go ahead and submit my answer. Okay, I'm happy with that. I want to submit my answer now.
Well done.
Okay, there we go. So that's in effect just submitted the slides, submitted the freeform activity as usual in Storyline, and I'm now seeing the layer appear on screen there. So there we go. That's a view of how agentic AI can transform and create the actions on behalf of the user based on natural speech. Okay, so as my second demo here, I've been given permission from my client to share with you a look at a proof of concept interaction that was built by myself through Discovery Learning that gives users the ability to engage in conversation with the central character of Alice in Typhoid Land. Now, the Alice in Typhoid Land project, by the way, is a public engagement initiative created by a team of academics at the University of Oxford, aiming to bring the subject matter of typhoid to life for audiences of all ages through the use of characters and stories that are set in the world of Lewis Carroll's classic novel. And with the help of Storyline and 11 Labs working hand in hand, I'm now able to engage in conversation with a character that I've built in Articulate Storyline.
Hello there, I'm Alice. What's your name?
Hi there, Alice. My name's Chris.
Well, hello, Chris. It's a pleasure to meet you. What can I tell you about typhoid today?
Hey, it's a pleasure to meet you too, Alice. I understand you can tell me a bit about typhoid and maybe the vaccines that were developed to combat it back in the day. Give me some facts.
Certainly, Chris. Did you know that the first typhoid vaccines were developed way back in 1896? That's quite a while ago. They were created independently by Amroth Wright in the United Kingdom and Richard Pfeiffer in Germany. Would you like to know anything else about typhoid or the vaccines? Or would you maybe like a summary fact sheet?
You know what, Alice? I like the sound of that. Could you please create a fact sheet for me?
Of course, Chris. I can certainly do that for you. Here is your typhoid fact sheet. I've created a typhoid fact sheet for you, Chris. It contains information about the first vaccines, what typhoid is, and some common symptoms. I hope you find it helpful. Is there anything else I can help you with today?
No, thanks so much, Alice. I really enjoyed our chat.
I'm glad I could help, Chris. It was a pleasure chatting with you too. Take care.
Okay, so hopefully what you saw there took place within the experience that was happening there was that the AI agent went ahead and performed an agentic action which was outside of the actual scope of the storyline activity. Within the WordPress website, what I've effectively got is a plugin designed to generate a PDF for the user and download in the browser session. So what Alice has done there, what the AI agent has done, is it has made a call to that function on the platform, given it the information and the data that it's passed through from our conversation, and then it's created a structured fact sheet for us. So let me go ahead and show that to you right now. And here's my fact sheet. And of course, I asked about the first vaccine, so that's what she's added there. But she's also added some other information there just to pad up my knowledge, as it were, on typhoid land facts. So that's really cool. And as I say, that's completely agentic and personalized to me. So if I were to ask a very specific question and wanted that in the fact sheet, Alice would have done that for me as well. Okay, so now we're moving on to our next sense, which is touch. And of course, touch controls in Storyline have existed for a long time, as what Storyline produces, through its inbuilt modern player interface, which is designed to allow on-slide experiences and actions to potentially be cross-device compatible. And this was something quite vital when working on the aforementioned Alice in Typhoid Land project, which was several years ago now when Discovery Learning had first been commissioned to deliver all of the interactive content that you can see being engaged with in this video to be accessible to guests of the Bodleian Western Library and the History of Science Museum exhibits. Now, this all took place at a time long before I really knew about the capabilities of JavaScript to augment what was happening on slide in Storyline. And of course, this was long before even the Storyline JavaScript API came about. So all of the rotation and other special effects that you're seeing here were actually achieved with just the standard Storyline triggers and motion paths. If I was going to be taking on this project today, though, my approach would certainly be a lot different. But I also think the capabilities of the modern browser web API toolkit is now much more robust to achieve special user interactivity, specifically geared towards touchscreen devices. The Pointer Events API specifically provides a range of event listener actions that extend far beyond what you would find in Storyline's inbuilt trigger actions, and therefore provides far greater scope for the types of interactions a user might perform using their finger or multiple fingers on screen. And here in this table on screen right now is a brief summary of some of those key interaction event types that I think you should be aware of as Storyline developers. The pointer down event, for example, is an extremely useful alternative to the standard mouse down event that you'll find in JavaScript, which itself does not encapsulate mirroring touch actions. Pointer down instead, as you can see, provides a means of applying a specific action to the mouse, pen, and touch down events, all within the same function. And along the same lines, there's also a pointer up event, pointer move, and enter and leave, effectively dragging and maybe dragging away from a specific area on the slide. Then at the bottom there are two events relating specifically to data that can be drawn from stylus devices, such as the Apple Pencil or the Surface Pen. The pressure property lets your script know just how much pressure is being applied on a decimal scale of 0 to 1 on the screen. And if required, the pointer type property can ensure that specific actions only apply if the user is working with a stylus device. Otherwise, fallback interactions or instructions could be programmed into the user experience. And now I'd like to show you two different examples of the Pointer Events API working inside of Articulate Storyline built projects, each of which are small demos. But the first I'll show you is actually something I've devised as part of an ongoing cloud project intended to be incorporated into a mobile game app for children. So you'll see what I'm able to do here is follow along with the instructions and draw a straight line from top to bottom connecting these 2 points. And as I do so, I can see that visual feedback on the screen of where and how far I've taken that line trace so far. And you can see the way I programmed this is that I can click away and what I've drawn so far will still be in place, almost like I'd drawn it with an actual pen or pencil. And then I can click and continue to draw. And then the next trigger action will occur as soon as I reach the destination. So all of that's taking place, as I mentioned, within JavaScript, using the capabilities of the Pointer Events API. And as you can see, not only does that provide us the ability to do straight line tracing, but we can also apply a Bezier curve in order to have that line trace be a curve shape as well. So there we go, I've just drawn my first letter. Okay, lastly, as a bit of a for fun project, I recently worked on something specifically for today's presentation and put this onto LinkedIn, so if you follow me, you might have already seen this. In effect, it's an activity that I created specifically for my Surface Pro here. Hopefully you can see this on the webcam if I just hold this maybe here. And the idea with this is that the Pointer Events pressure properties are translating into the storyline activity in order to make things happen on the slide. So if I just start just lightly stroking the cat here, hopefully you can hear that. The cat's enjoying getting a stroke there very lightly with my pen pressure. But let me now go ahead and apply some more pressure to the screen. So there we go. The cat did not like that. So that value, as it were, between 0.6 and 1 was the kind of start and end point, as it were, of the tolerance for that. And then anything below that is going to eventually make this happen. So Storyline, the JavaScript API, is giving me that hand shape over where I'm dragging my mouse cursor. So that's really nice. And then as soon as I apply any further pressure, so yeah, rule of thumb, don't annoy your cat too much because you might pay for it. So now we come to our sense of smell. And of course, you're looking at me right now and thinking, what am I going to pull out of the hat for this one? Well, truthfully, I'm not entirely sure. But you know what? When you're in a bind in your presentation like this, all you have to do is throw a funny meme onto the screen, and hopefully that will distract the audience enough that they won't notice. So let's deploy our emergency nose-themed meme in 3, 2, 1. Ah, terrific. But you know what? By some fortuitous happy accident, this has brought us nicely onto the subject of controllers as a peripheral that we can explore to provide users with another method of interacting with digital experience. But is it actually straightforward to effectively plug one of these devices into our computer and say control triggers in Storyline by pressing, one of the buttons on the pad? Well, the answer is yes, thanks to a web API called the Gamepad API, which is designed to make the process of incorporating game controller actions into browser-based experiences super easy to develop. So much so that I have 2 examples here to show you that are built in Articulate Storyline. The first is essentially a direct tech demo implementation to show how I'm able to control a digital twin device here on screen by just plugging in my controller to my laptop, and you'll see that the JavaScript that I've written here to connect to the Gamepad API effectively does the work for me and converts all of the actions taking place on the pad into triggers that can then make things happen on the slide. So I'll go ahead and plug in my controller now and then preview this activity. Okay, so I'm now previewing my project, and as you can see, I'm just doing this entirely within Articulate Storyline. I don't actually even have to publish the project out of Storyline to see this in action. And then hopefully if I hold the controller up here so you can see what I'm doing, if I press, for example, the A button, B button, X button, you can see that those states are changing on the screen. So in effect, the JavaScript is picking up on the action taking place on the controller, and then I have triggers set up in the storyline or on the storyline slide in order to change the state of those elements on the slide itself. And I've programmed the ability to click on the shoulder buttons there, the direction, the digital direction pad there, and also the menu and start buttons. And then using GSAP, which is an animation framework that we can work with in Articulate Storyline, I've been able to use that in order to have the analog sticks move in the position where I'm moving the sticks here. So there you go. So left, right, up, down. All of those are picked up as well in Storyline. So because this project actually works in Articulate Storyline, maybe you have a controller at home that you'll be able to play with. I'll make sure to pass this project on to David to include this along with the recording that you're watching right now on Articulate's website. So with all this capability using the Gamepad API, we can, if we wish to, effectively use the storyline development environment to create game-based experiences that can be controlled by the video game controller. This example is actually a project that I walk my advanced animation workshop students through at Discover eLearning. The character on screen is typically controlled with either keyboard or pressing arrow keys on the screen. But you can see that if we incorporate the Gamepad API, we now have another means of the user being able to engage with this activity. And as you can see, if I go ahead and press the direction buttons here, I can start to move my character along the path. And you can see you can go up, down, left and right. And then the idea is that I would bring him over to the save crossing zone here. And that's where he would then be able to click the button in order to start safely crossing the board using the crossing. Okay, so we come to our fifth and final sense of taste. And you know, all of this presenting work really does make you thirsty. So thankfully I have a project here that I developed in Storyline, and as you can see, if I take a sip, it's going to give me a beer fact on the screen. So let's go ahead and do that. And there we go. My beer fact has just been revealed on screen. So what you just saw there was achieved through another set of web API properties and methods that exist to help us tap into various pieces of data that we can obtain from the mobile device itself to help drive a user experience. And you can see once again, I've annotated an event name list here with some examples of how it can relate to a learning experience that we might design, for example, in Articulate Storyline 360. Okay, so that now completes our odyssey through the senses and the many interactive methods that we have explored today. For sight, we saw GPT Vision up and running both with the camera, with our webcam, and what was being captured on screen. For sound, we looked at conversational AI models that can also be programmed with agentic slide triggers. For touch, we take a look at the Pointer Events API, which provides a number of different interactions that we can create and take advantage of within our Storyline projects. We took some creative liberties with Smell and turned this into a look at the Gamepad API, which can be used to effectively plug and play a device like an Xbox One controller in order to have that control the experience that we are developing. And then finally, for taste, we used that again creatively to take a look at some device-based events and some navigator methods that allow us to get properties directly from the user's device. Okay, so I'd like to leave you with a bit of future gazing to consider where things might be heading next in the world of technology and how this could continue to shape the way we think about interactivity. Right now, some of the most influential minds in tech are rethinking how we as human beings will engage with our devices in a world where AI is no longer emerging, but embedded in daily life. You may have seen this photo of OpenAI's Sam Altman and Johnny Ive, the legendary designer behind many of Apple's iconic products. His company, I.O., was recently acquired by OpenAI in a deal reportedly worth $6.4 billion. And that's a staggering figure for a startup, but it sends a clear signal that the interface itself, the way that we physically and cognitively interact with technology, is being considered as the next frontier. And it's not just OpenAI. Valve CEO Gabe Newell is also thinking along the same lines, exploring the future of neural interfaces that allow users to control systems directly with their thoughts. He's investing in a new competitor to Neuralink with the ambition to enable true mind-to-machine interaction. The potential here is vast, especially when we think about accessibility. For people with mobility challenges or medical conditions, this kind of interface could be life-changing. And for developers like us, it's a reminder that we're not just building for the present, but helping to shape a future where human-computer interaction could become more direct, intuitive, and inclusive than ever before. So as I keep saying quite a lot these days, I think it's a really exciting time to be a developer right now, because we're not just working with today's tools, but collectively we're laying the groundwork for much bigger things still to come. So thank you very much to everybody who joined our session live, and anybody who might now be watching this on repeat. I very much enjoyed spending the time with you, and I hope to do another session in the future. I hope that you'll connect with me in one way or another to continue the conversation. You can discover more about my company and the work that I do through the link that you're seeing on screen to the Discover eLearning website. And as well, you can connect with me on LinkedIn and also my YouTube channel, where I post most of my ideas and project results, especially working with Articulate Storyline.